step further here, we start to get into trigonometric equations in which you could use SOHCAHTOA to solve them, but it'll take you forever. And the whole purpose of these videos is to make your life easier so that you graduate, but you also understand the reasons why you do certain solutions, as opposed to feeling like you graduated and it's all a blur and high school felt like one long 4-year academic hit and run accident. So supposing we come up with something like this. Let us say cotangent of theta divided by cosecant of theta equals, well, this is going to eventually turn out to cosine of theta. Stuff we're just pulling out of thin air here. And a lot of people look at the thing like, what next? There are patterns to problem solving. It helps to remember that all of your basic trig formulas, if you ever noticed, even if you don't memorize them, always seem to reduce back down to the simplest beginning step, which are sine and cos. Not too many formulas at the basic level are expressed in terms of cotan, cosecant, or secant, or other weird stuff like that. They always come back to sine and cos, which are our two basic pillars. Even tan is a derivative of that. I'm going to talk about that right now because it will help us to solve this. Tangent, as you remember, is the same thing as y over x, using the stuff from the last video. Go back and take a look on your own time. So, if we go back to sine, sine of course was was y over radius, cos was x over radius. If we take sine divided by cos, for example, we take this and divide it by this, what we have is a situation here now, we'll just get rid of this stuff here, y over r divided by x over r. Now, we know that when we divide by a fraction, we can turn into a multiplication question here. So there's our y over r on top. We can multiply that by this thing as long as we flip it over. So this becomes the same as this. Repeat that again. We take this divided by a fraction. We can turn into a times question by taking that thing that we divided it by, which is this, and flip it over. Keep that in mind. And we can prove, therefore, that, now this cancels out, this cancels out. So r divided by r cancels out, y over x, which is this. Therefore, tan equals sine divided by cos. We're going to use this. We now know that cotan, of course, if you're not sure what to do with the question, just start converting it into other things that are simpler. Cotan, of course, is 1 over tan theta. And notice I put it in brackets so there's no confusion later on when we have a whole bunch of fractions being stacked up. Cosecant equals 1 over sine, like that. We now remember what we just talked about, namely that we can turn this into a times question by taking this and flipping it over. So sine theta over 1. Don't forget that over 1 part. So this has now gone up there, and we can cancel it out. But we also remember that tan is the same thing as sine over cos. So we have 1 over all this stuff, and tan now becomes sine over cos. Even if it's not clear at this point where we're going, remember, always simplify everything down to sine and cos, and stuff will start to cancel out. Of course, it's all of this stuff here, which became that, times this thing here, which is sine over 1. So far we haven't changed that part. But remember again that when we divide something, in this case the something is the number 1, divided by all this stuff here, we can turn that into times by flipping this thing over here. So it now becomes cos theta over sine theta times that 1, when we don't have to put the times 1 because that stays the same. So this thing here just became that. We flipped it over because it's 1 over this fraction times, this comes down again, we still haven't changed it, sine theta over 1. Oh look, sine divided by sine. We can cancel this out, and now we have cos over 1, which of course is just basically cos theta, which is what we set out to prove. So all of this stuff here, if we convert it into what we are more used to, which is cotan becomes 1 over tan, and then tan becomes sine and cos, we can start to cancel stuff out, and we end up with this, which of course is what we set out to prove that it equaled. Even the most complex equations can be broken down this way, and we will tackle more of this in the next video. Remember, these videos are to help you guys, and I do this because even though your teachers love you, I love you more.